How do you even solve vector addition? So first we have vector A. It has horizontal component 2 and then vertical component 3. We have vector B. We have horizontal component 4 and vertical component 5. We then take both the horizontal components and add them in one place, and then we do the same for the vertical components here, and the result is our answer. So this is how you add vectors. In theory, this is vector A and then this is vector B, which are both added, and this is this result vector C, but we haven't named it. Okay, so let's name it vector C. This is a very good question. Are vectors and points the same? Vectors and points are not same because vector can exist anywhere on the grid. Like same vector can exist in multiple places. Look, this vector 1 1 is existing in 3 places, but the point 1 1 cannot exist anywhere else. This is it. So that's why vectors and points are quite different. Okay, so here I have a more detailed look for how vector addition works. So basically you have this vector 10 12, and then you have the vector that adds into it, right? How much is added? Again, I'm adding 10 horizontally and I'm adding 4 vertically, and this is the resultant vector. But instead of writing 10 2 plus it's not 10, is 10 added? Yes, 10 is added. 10 4, we can simply just write 20 16. It's less redundant, right? And it's actually easier to grasp. Fact: multiplying all the components of a vector by -1 reverses its direction. So I'll show you this in 2D first. So we have the vector 2 1. We multiply it by -1. We get the result -2 -1. So this is the vector first, and then when it's multiplied by -1, this is the result. Notice that both its horizontal and vertical direction are reversed. Now instead of 2, the horizontal component is -2, and instead of 1, the vertical component is -1 when it's reversed. Now in 3D, if we have vector 2 1 and 3 and we multiply with by -1, we are resulted with -2 -1 and -3. Let's see how the vector was in the first place. This is how the vector was in the first place. Look, one more time. Oh, the video stopped. But this is how the vector would be, like this. But when we multiply it by -1, this is how it goes. So the vector literally shifted from 3 up to 3 down. It looks pretty much same horizontally, but it goes down, so you can see it like this. So these are the changes in 3 dimensions, but it's basically the same, just reverse the direction. So now we'll talk about triangle law of vector addition. In this law, we simply just join the tail of one vector in the head of another. So this is the tail of, I'll show you correctly, this is the head of one vector, and then this is the tail. It's not clear, let me show it to you. So let's say this is vector A, then this would be its tail, and this part would be its head. So you join the head and the tail, and then you're resulted with C, vector C. But one thing to notice is the resultant vector, which is vector C, is in opposite direction. So here, how is it in the opposite direction? First we follow this, then this makes sense, right? It's clockwise. and then she should have been this, right? But it's in the opposite direction, so it goes anti-clockwise. This is triangle law of vector addition. Now we'll talk about parallelogram law of vector addition. If we do not want to, we cannot join the heads and tails of two vectors, we can also follow parallelogram law. In this, we simply just draw out A, and then we draw out B like this, and then the resultant comes from the diagonal of the parallelogram. That's why it's called parallelogram law of vector addition, and this is how it's solved.